Hello students, in this video we'll learn to develop fuzzy logic toolbox for any fuzzy based applications. So fuzzy logic toolbox is a software. It is used to create any fuzzy inference framework inside a MATLAB environment. So in this video we are going to perform some fuzzy applications without any programming. We are going to just use graphical user interface tools in our MATLAB. So before going to this, we'll first learn what fuzzy inference is. Fuzzy inference, it is a process of formulating and mapping any input to an output using certain fuzzy logic. So this involves membership functions, logical operations like or and not, all types of operations, and certain fuzzy rules. To frame the fuzzy rules, we'll go for if then else syntax. Then this is applied in all fields like automation, data analysis, classification, and even in healthcare sectors. So here we are going to use two types of fuzzy inferences. One is Mamdani type and another one is Sugano-Sugamato type. So in Mamdani inference system, each output membership function will act as a fuzzy set, and in Sugano-Sugamato it expects the output membership function to be either in a linear form or in a constant type. So to go into this fuzzy logic toolbox, first we are going to develop a tipping problem statement. So the tipping problem statement here is that, so given a number between 0 to 10, so that represents the quality of service in a restaurant. So here the problem we are going to consider is the restaurant. So we are going to give the tip based on the quality of service and the quality of food. So these are certain rules to be taken into account while giving a tip, and the probability is also given here. So the tipping is average and generous and tip. So now we'll go, and this is the cheap tip 5%. So now we'll go into the MATLAB programming. So here based on the quality of service and the quality of food, we are going to determine the tip. If the service is poor or the food is rancid, the tip is cheap. If the service is good, then the tip is average. If the service is excellent or the food is very delicious, then the tip could be generous. So based on these rules, we are going to give the tip by using the fuzzy inference system. Let's go into the MATLAB. So to perform this, we are going to use the programming tool MATLAB environment. So in this command window, we are going to type fuzzy. Since we are going to use the fuzzy logic, so we are going into the fuzzy. So this is our editor window. So here we are going to consider two inputs. So we have only one input. This is the inference system and this is the output. Here the inference we are using is the Mamdani model. So Mamdani model will expect the membership function output to be in the form of fuzzy set. So here we are going to add input variable. So now see, we have got two input, one output. So this we term it as two input and one output model. So now click, you get the red highlighted. So here the name is given. So now we are going to make it as service, since the two input parameters are service and food. So service, now it is service. The next one is the food. So the output is tip here. Now we are going to change the inference. So this we have to go file, export to workspace, and it is the tipper. So now you see it has been changed simultaneously. In the workspace also you have the tipper. So this is the tipper. So service, food, these are the two inputs. Tipper is the inference using the Mamdani model, and tip is the output. So now we'll go for the first input. So click this, you will get the membership function editor. So this is the FIS editor where we have our schema. The next one is the membership function editor. So if you click the input, you will get the red highlighted. So in this, now our range of the graph is to be 0 to 10. You can see display range gets also automatically changed. And now we are going to remove all the membership functions that has been backed up earlier, so it's just like refreshing. So remove all membership functions and we are going to add the membership functions new. So here we are using the membership function to be Gaussian, and for service we have three input variables, so we are having the number of membership functions as 3. So now you see 3 membership functions we have got. So click to the first membership function. Now the name, since we are speaking about the service here, we have 3 membership. One is poor, good and excellent. So for poor, so this follows the Gaussian membership, and we have certain input parameters for this. So this is user friendly, so you can determine as you like. So I am fixing 1.5 to 0 here. You could see witness the change in the graph. So next one is second membership. So here we are speaking about the good quality of service. So this also follows Gaussian membership, and the probability here is 1.5 to 5. Yes. So next third membership, here we are speaking about the excellent service performed by the restaurant. So this also follows the Gaussian membership function. Here the parameters value are 1.5 to 10. So you can see 1.5 to 0, 1.5 to 5 and 1.5 to 10. So now we have got the service membership function. Now we'll move on to the second input, that is food. So here also first we have to change the range. So it is if you are giving 0, automatically the display range changes, and the second step is to remove all the membership function, then add the membership function. Here we are using the trapezoidal membership function. So speaking about the food, we are going to tell only two things. One, the food is rancid or the food is delicious. So just two is enough. So we could see two options, MF1, MF2. So MF1 we are going to tell whether the food is rancid. Yes, rancid follows the trapezoidal membership function, and the parameters are 0, 0, 1 and 3. Yes. So next is speaking about the second thing. So here the food is very delicious. So food is delicious here, and the membership function, could it be default values? So next we are going for the output. So here the output, so the name of the output here will be the, so here first the range we are going to fix it to be 30. So this also becomes 30 here. So here we are going to give three tips. One, it could be either cheap, next one is average, and it could be generous. So here also we can remove all membership, we can add the membership functions, and it could be trim f. So three membership functions. So first one is cheap. So we'll give here cheap membership function. So cheap here 0, 5, 10. Because cheap we have given the probability to be 5%, so it could be either +5 or -5. So we place it between 0, 5 and 10. So next one is average. So for average we have given like 15%. So plus 5 minus 5 will have 10, 15 and then 20. So third membership function, here it is generous. So here for generous we have the maximum of 25. So we give 20, 25, 30. So this is why the reason we have made the range as 30. So since we are going to have the parameters till 30. Yes, now we have given for service, for food, and then also for the, yes, so that is why the reason we have given 30 for the tip, because for cheap we have 0 to 10, and for average we have from 10 to 20, and for generous we have from 20 to 30. Since the percentage lies in between, we can have plus 5 minus 5. So that's why the reason the range varies from 0 to 30. So yes, now we have for service, we have for food, and also for tips. So now it's the time to frame the rules. So to this we have to go to the edit menu. So rule, now we have a rule editor open. So now let's have a glimpse of our problem statement. Service is poor, food is rancid, then tip is cheap. So here you can notice the connection logical operator or. So yes, now what we have to do is we are going to fix it. So service is poor, food is rancid, then the tip is cheap. Use the OR gate. Now use the tab add rule. You can also delete a rule. You can also update the rule. So now the second rule is, if the service is good, no comment about the food. So none. Then tip is average. So add the rule. So next, service is excellent, food is delicious, then the tip is generous. So now we are going to add the rule. So these are the three rules taken into account. So now we have framed all the three rules. So now we are going to view our, so this is the output that we have got. So now you see, for the service of 5, food 5, we have the tipping value of 19.2% from our total billing. If you vary the service, if you vary the quality of food, you can see the variation in tip. So now let us imagine a service is excellent, food is also very delicious. You can see the tip automatically goes for the maximum of 25 percentage. So this is the variation. Now we'll also see the minimum. Service is 0, food is excellent, then only the tip is 15 percentage. Food is also 0, then tip is the basic value of giving, just the minimal norms 5 percentage. So this is what, if you vary the probability, you can witness the amount of tip you could given. So this is what now we have generated the tipper logic without using any program. So this is the schema that we have obtained. So fuzzy method is centroid, and the input and the output structures we are using. So this is what generating a toolbox, GUI toolbox, without the use of any programming. So this is our GUI toolbox, and this is our input, and this is our output, and this is the inference system fuzzy schema we are using. So without any program, just by using the GUI tools, we are going to create a fuzzy logic based application. So thank you.